If you are expecting a standard passenger load, the pack flow selector can be selected to normal. Changing the pack flow selector does not cause any change on the ECAM page. The selector affects pack flow only when the engines are running and supplying bleed air to the packs. Should the APU be supplying the air, or should one pack be shut down, the airflow automatically reverts to high, regardless of switch position. Additionally, the flow control switch is a request switch. If the system cannot maintain comfort level at the requested airflow, it will automatically shift to a higher airflow. In situations of low passenger numbers, the pack flow selector can be set to low. This has the effect of reducing the bleed demand from the engines and will therefore save fuel. Occasionally, with a full passenger load and high ambient temperatures, it may be necessary to select high pack flow and cold to reduce the cabin temperature. Using high pack flow will increase the bleed demands from the engines and use more fuel. Once airborne, the flow selector should be returned to normal and the temperature selectors adjusted as required. It is now time to get some air to the packs. As the APU is already running, set the APU bleed to on and watch the ECAM indications. Switch APU bleed to on. Notice the APU valve indication has changed to inline green. The crossbleed valve has automatically opened. Notice the crossbleed switch is in the auto position. Both feed lines to the packs have been connected. Let's now look at the packs. Notice the fault lights are extinguished due to the air supply. The pack flow valves are opened. The pack flows increase. The bypass valves move. The supply lines to the mixing unit are now connected. Both packs are now providing air conditioning. Let's look at temperature regulation of the air conditioning system. This is better seen on the ECAM conditioning page. Call the ECAM conditioning page. We will concentrate on the upper part of the page. Of particular interest here are the zone temperatures and the duct inlet temperatures. Temperature regulation is achieved the same way for all zones. We will demonstrate the concept using the cockpit zone as an example. The cockpit zone temperature selector is in the 12 o'clock position. In this position, a zone temperature of approximately 74 degrees is demanded. Since 65 degrees is less than the requested 74 degrees, the zone controller sends a command to increase the amount of hot air needed. As a result, the trim air valve opens. The zone duct temperature increases as warm air is supplied to the cockpit zone, and the cockpit starts to warm up. When the cockpit reaches the requested temperature, the trim air valve will move toward closed, reducing the amount of hot air. It will then move as required to maintain the zone temperature. During engine start, pack valve operation is automatically terminated. When the engine mode selector is placed to ignition start, the pack valves automatically close, thus routing all APU bleed air for engine start. After engine start, the pack valves reopen. Because the APU bleed valve is still open, the APU will furnish air for the packs. Notice that the engine bleed valves are still closed, even with both engines running, but that there are no bleed valve fault lights. This is because APU bleed has priority over the engine bleed. In our example, the APU is no longer required. Switch off the APU bleed. When the APU bleed switch is selected off, the APU bleed and cross bleed valves close. The link lines disappear, and both engine bleed valves open, supplying the packs with bleed air. Notice that the pack flow reduces. This is because the engines provide a higher flow rate than the APU. Also note that the air conditioning control panel is now in a normal lights-out configuration. When the APU is shut down, the APU symbol on the bleed page is removed. The Fahrenheit temperature scale, UAL aircraft, reads from 64 degrees at cold, brisk, to 86 degrees at hot, toasty. During the flight phase, the air conditioning system will work automatically, and the only likely pilot input that may be required is to adjust zone temperature. Let us assume that you wish to cool down the cockpit. To demonstrate, please select the cockpit zone selector to cold. Because you have requested a cooler temperature, the trim air valve moves toward closed. Cool air from the pack itself will supply the cockpit zone. After landing and engine shutdown, the system can be set to run from the APU, switched off completely, or an external conditioning unit can be connected via a low-pressure connection point on the underside of the aircraft. The low-pressure air is fed to the mixing unit and then into the 3 zones. There are no indications in the cockpit to show that an external conditioning unit is in use.